which is a small world network. Network is a particular type of complex network. The internet, computer connectivity is a small world network, and so is the human brain. So yeah, so I designed Leximancer to bring all those things together as a tool where you could put in text and it would break it down into thematic, like putting light through a lens where you get a spectrum of colors. You put text into Leximancer and you get a spectrum of themes and how they overlap. And then you can inspect that to understand the data. So you can, understand a lot of data and understand it very quickly and without bias. So that was my intent. And I'd finished that by about the end of 2001 and had a prototype. So from there, we started trying to sell it from UQ and commercialize it. And it went from there.
That sounds like a good product. Yeah, well done.
Well, thank you. It just seemed like the right way to do it. It still does, actually, even after all these years. Yeah.
Now, guys, we've just had another participant join us, Karma. Karma, can you hear us clearly? Audio is not quite coming through. You just maybe check your microphone so when it's time to participate. So, all right, everyone's starting to come on through now. So we're getting a couple of extra numbers. So while we've got the new participants coming through, look, I'm from the business operations side of Leximancer. We're really lucky today. We've got our founder, Dr. Andrew Smith, an inventor, to give us just a brief overview of Leximancer in general. We are a little bit behind time. We all got on a little bit late today. So I think we'll let Andrew start with that. So it'll give you a brief background. Then we'll go into some more advanced features of the product. And then at that stage, if you do have any questions, just pop them through in a note. And then we can go from there. Okay.
Lucas, can you enable screen sharing for me, please?
Yes, I shall. Why is it not letting me?
You found it? It's next to the share button, but there's a little pop-up button next to the share screen button. Okay, I think you got it. All right. So there were so the people who registered, quite a few asked to just for the basic training. So I will start with that. Try to cover it fairly quickly in case there are some advanced questions. There were a couple of advanced questions that people registered for, and someone also has a technical problem. We'll try and get it to that before the end with running the software. So hopefully you can see a slide. Lucas, can you see a slide?
I've got the slide up, Andrew. I can see that.
Okay, right. So Leximancer is, as I was saying right at the beginning in conversation with the first person who joined, I developed Leximancer as a way to analyze qualitative data in a faithful way to create valid and models which are faithful to the data, which capture the meaning in the data, without trying to be reductionist or positivist or whatever those negative words that qualitative people like to assign to computer methods, And some of that's true, right? So some text analytics methods do throw away all the nuance and complexity of meaning in text. So my aim was not to do that, which is why I was using a complex systems method. And complex systems is a research method for actually capturing the complexity in real world data, where older methods did not. So yes, Leximancer is a tool to model the meaning within the text, potentially large amount of text. So what shape does our model use when we extract the text? Well, the shape it takes is called a complex network, or a small world network actually, which is a type of complex network. This is a paper from 2001 where researchers began establishing for real what the structure of knowledge within text is. So you imagine you have a document, set of documents, whatever, an archaeological set of papyrus scrolls, whatever it is, that natural language contains it has objects within it which then have relationships between them. So a story can have, a dog, a postman, a letterbox, a kennel, and has relationships between them. And those, the structure of that knowledge within the text usually, pretty much always, takes on this form of a complex network. So it's a network of links between nodes. The nodes are the actors or the entities, or the concepts in the text, and the relationships are just that. They are relationships created when you state that the dog bit the postman. You're establishing a relationship there. And if you get a lot of text, this network gets bigger and more complex as you go, and it has certain statistical properties which are always there, which is interesting. It's interesting that the distribution of frequencies, how many times these concepts appear in the text and how many connections they have, there's always the same sort of distribution. So it is a very particular type of network. We're not just saying it's a connection of things, it's a very particular type. So Leximancer took that on board. And so then what I wanted was a technique which would extract that network from text so that you could put in text, and within a few minutes, you get one of these complex concept networks, which you could then begin interpreting. We call that sense making, but it's interpreting the network. And part of that interpretation, a really important part, is drilling down, looking at the underlying text. So you do understand in detail the content behind every part of that network, or the parts that interest you anyway. So Leximancer is a type of assisted content analysis. This is like the one-line statement of what it's about. Its purpose is to let the text data generate a transparent model of meaning, which you as the analyst or the researcher can interpret. And you can interpret all parts of the model. It's not some sort of black box AI that you have to take on faith. That's never what it was meant to be. It's to support people. It's to support the gaining of understanding and awareness of what's in your data. In a reproducible, unbiased way, sure, but it is about learning. It's about learning what's really there, and quite quickly too. I can get a set of data that I've never seen before, and within a couple of hours, I can get a good understanding of it to the point of being able to explain it to someone else. And that can be megabytes, gigabytes of text, and you can do pretty well quite quickly. That's not to say it's an easy task. You're trying to load a lot of information into memory and into your understanding, but it's doable rather than having to read it for weeks and do manual coding. So content analysis, I don't want to dwell on this for too long. Its content analysis is for analyzing qualitative data, usually text traditionally, but it can be images and video. Its core techniques are breaking the text into chunks. Usually it could be a sentence, phrase or a paragraph, can even be a whole document, and then coding that. And along the way, you have to work out what concepts you want to code with. What ideas do I want to measure in the text? So that's a really important part of content analysis, working out what you want to code for. Right. Content analysis had a history. It evolved over time. Maybe, starting early in the 20th century, they were looking at just frequency. So they were coding for propaganda and newspaper articles, and how many times is propaganda used in, let's say, a particular German newspapers, English newspapers, French newspapers, and is that changing over time, that sort of thing. And then they said, well, instead of just coding for single concepts in each document, why don't we look at small chunks of text, like a narrative unit, whether it's a sentence or a paragraph, and why don't we code for all the things that have been bound together in that paragraph? So when people state a narrative, they do it in an utterance or by writing a paragraph. And if we code all the things that they mention together, we can start seeing the relationships that they're asserting. And so that's what relational content analysis is about. These days, I would probably rename that to be concept network analysis, because you are building a network of relationships. Then once you've got that network, well, can we visualize it? Can we get a picture of what that network looks like? That can be called cognitive analysis or just network mapping. So it's visual-oriented sense making, if you like. So you still have to do the job of the researcher or the analyst. You still have to go and get your data, which means sampling from a relevant population. You have to decide what unit of text you want to code. But Leximancer by default uses 2-sentence segments. And an important thing to reflect on is you're supposed to think about what you code into the text. Now, it's probably fair to say that Leximancer, because when you start Lex and you put some text in, it takes a default strategy with that. If you put in text, it will build a map of that text, but it's making a decision about what concepts to extract. It's trying to get a relatively not a huge number of concepts, a reasonable number of concepts that will still code almost all the content that you give it. So it's Occam's razor, if you like. It's trying to get the simplest model, which still covers most of the data. But that isn't necessarily what you need. If you've got a particular research question or you have a theory you want to test, then you probably don't want that sort of exploratory analysis. So by default, Leximancer does an exploratory, grounded analysis of the text. If you don't want that, you can take control. You can turn off the automatic concept selection, and you can hand specify your own concepts. And you can still, the machine learning will still help you with your hand selected concepts by filling in the vocab lists for each of those concepts or dictionary items that you want to create, and doing the coding and the model building, of course. So yeah, I mean, I think most beginner users of Leximancer, they don't see that you can take control and specify your own concepts and your own coding frames. They just see the automatic map. We've talked about Leximancer extracting concepts. This is kind of how it does it. They're called latent concepts. There is a technique, it's solidly grounded in research and in the literature, called latent concept analysis, latent semantic analysis, topic modeling. They all kind of mean a very similar thing. What they do is they assert that because people have written the content and people were guided by concepts in their mind, in their brains, their neural networks. So when they thought of, in this case, a firearm like a rifle, they had a bag of concepts, a bag of words in mind to describe that concept. And so they draw terms from that bag of terms, a bag of words, to describe that. And so if there's a sentence where they're talking about a rifle, they're probably drawing from this similar bag of words. They're going to describe it. So that can be reconstructed. So the software can find these groups of vocabularies that describe a dog, a cat, a rifle, culture, sport, whatever it is, whatever idea it is, the software can reconstruct from the language what families of words were being used by the authors from their neural nets, from the vocabulary and their language knowledge in their brain. And sure, you might think, well, what if all the authors have different language models in their brain? That's a very good question, and you need to be aware of that. If that's true, you should probably divide your text into, text from one set of people who have a language model more or less in common, and then a different set of text from a different set of people who have a very different language model, and do those as two separate Leximancer projects. So you're not trying to load multiple models of language into one Lex project. Okay. So this is a latent concept that's been discovered around the idea of the rifle in this document. And you can see the flavor of the text. They're related to a rifle. They're predictive of the idea of a rifle. So if someone mentions bolt action, there probably is a chance that they're talking about that rifle. And so this number indicates that probability, how likely each word indicates what concept is being talked about. And what do we do that for? So Leximancer can then go and code the text. Can say if someone writes that A. Heidel bought a man like a Carcano rifle from the a man like a Carcano from the Irving Sports Shop, it can predict that they're definitely talking about a rifle, even if they don't actually mention rifle, because we have other words which are indicative, if you like, predictive. So that's what that's for. It means that you can get much more coverage with the coding, and find where people are talking about an idea, even if they're not using the obvious keyword. Coding is like, I don't know if you haven't seen coding, it's like classifying or tagging text, or even marking an assignment if you've ever done that. And then Leximancer will count how many times concept codes co-occur. Let's call that bookkeeping or accounting. So counting how many times a concept appears how many times it's coded into the text, and how many times it's coded with each other concept. And that, if you get the drift here, builds a network of concepts. That's what coding looks like. If you've never actually seen it, one way you could think about it: pieces of text coded with the concepts that are indicated by the words. And by measuring how many times these pairs of concepts co-occur, you get this thing. Sorry, is there a question? I can't really hear you, sorry. Maybe if you typed it in the chat, if you can't get your audio working, you could always type the question in the chat box. Just bring up my chat box. Is that Karma? Was that Karma who was asking a question? No. Okay. Well, if you can, whoever that was, if you can enter your question in the chat box, I'll try to get back to it. So this is like the concept co-occurrence matrix. So once the coding is done, Lex goes and counts how many times each concept codes together with each other concept, and it builds this thing here. Like you might see in Excel, but it looks at concepts versus concepts, and you get the co-code count. So what can you do with that? Well, you can build a schema, and Leximancer does. So instead of having to analyze this, which is rather a daunting, difficult task, the software could try to represent that as a diagram, an infographic, a conceptual schema, whatever you want to think of it as. Now, this is not a Leximancer map. This is taken from an article marketing research, but it is a concept schema which was derived from a concept network, and you can see it's a network of ideas. Each bubble is an idea. The connections are. So what does a connection mean in this sort of graph? Connection means that these ideas were talked together quite a lot. The Volkswagen Beetle idea was talked about along with neat colors reasonably frequently. And if you join the lines together in longer chains, you get narrative. The Volkswagen Beetle has neat colors because it comes in lime green. So you see it's telling you the main stories that are contained in your text, along with the main ideas. Some connections are strong, some are weak. That shows you how common or how correlated they are within the stories. But there's another part of these maps which people can miss if it's not explained to them, and that's distance. So if we look at distance vertically, there's a thing called a dimension or a factor. And here I'm alluding to factor analysis, which is another method that's used in social sciences and marketing and tourism and things like that, where you have a lot of variables and you want to look at, let's say I have 50 variables and I have a co-occurrence matrix like that, but I want to boil that down into maybe two dimensions of meaning. So this is one way to do it. You can look at the dimension. So the vertical dimension here goes from fun, neat, silver, easy up the top to mileage, price, miles per gallon, and traction. Now, I mean, as I see it, what these have in common is they're aesthetic, they're fun, they're emotional, affective, whereas the bottom is more practical and pragmatic. But I know there's good is down here as well, but it's more to do with how the car handles and how much you have to pay rather than visual aesthetics. So that's a dimension you can find. And there's probably a dimension that goes side to side across the map too, if you looked at it carefully enough. So you should look for these dimensions because you can really, this is where the really interesting research topics, findings can be discovered, looking at the dimensionality of the Leximancer map. So this is a Leximancer map based on a transcript. It's actually 21 days of a commission of inquiry, all transcribed, so it's quite a lot of text. And this is the concept map, and there are lots of stories in here, a lot of information here. But you can see there is a long axis to the map, and that carries an important dimension. And if I look at the top end of it, it seems to be about legal procedure and evidence giving. You can see the inquiry, the chairman, they're looking at evidence, paragraphs, pages, that sort of thing. Whereas the bottom end is looking at the material world, what actually happened in the incident. So this is engineering, this is law. And you could ask yourself, how does the law regulate engineering? Well, I guess if you look at the interface here, the dividing line, it's about risk assessments and premises and inspections and safety, health and safety. It's about evidence and compliance. So you get an idea here that, right, well, at a higher level, this is about how do a bunch of people get together in a room and try to control risk in the real world. And it's through lawmaking and mandating compliance. Anyway, so I found that interesting. And when I've been working with academics and researchers who do find surprising things which can be published, it is often through this technique of looking at the factors, at the dimensionality of the concept map. All right. So things you can do with it. You can look at publications in a bunch of PDFs in the literature to do a systematic review of a literature, or developing definitions from the literature. You can look at spreadsheets, like a survey, or you could interviews as well, and you can include in that demographic information, such as who gave each response, what were their demographics, their gender, their age, their maybe whether they from a rural or a metropolitan region, things like that. You could also look at media, social media, newspaper media, um, transcripts from Parliament where they have speeches, and that's really interesting. Looking at framing, how issues are framed by different media actors, like different newspapers or different political parties. Leximancer is very good at discovering frames, and by frame I mean the way that an issue is well contextualized, good or bad, healthy or unhealthy, that sort of thing. If you want to know more about content analysis, I enjoyed this book, Weber Basic Content Analysis. It's short and to the point, didn't waste my time. If you want to use Leximancer in a publication and you want to cite, a paper which validated the tool in the literature, then this is a peer-reviewed publication from Behavior Research Methods. That is on our website. The PDF is on our website. If you can't find it in Google Scholar, here's just a couple of papers that I really liked that use Leximancer. But if you want to find more, like last week, I looked on Google Scholar and searched for Leximancer. There were about 7,000 citations that I found. So, pretty much whatever you want to use it for, you're likely to find an article that's already been published that shows you ways that it could be written up and published. All right. So that's the introductory slides. So good time for questions now. Yes.
Yeah, so just a passing comment for that may help. Maybe use lit maps for this, and you might be able to find some more concepts. But anyway, you'll see the citations and things.
Yeah.
I've got a query. So this session's about the concepts behind Leximancer, which is useful. Am I able to ask questions like I'm trying to do something and it's not behaving as expected, or
That comes next. So
okay, so I'll wait for other questions then. Yep.
for beginners, I feel perhaps it's old-fashioned and traditional, but I feel that understanding the framework of what's going on here, that this is a concept network method grounded in relational content analysis. I think if you understand that, then there are a lot of settings behind Leximancer if you look. And I think they start to make a whole lot more sense if you understand the framework of what you're trying to do, rather than just clicking buttons, hopefully, because if you do that, if you click settings and you get lost and the map starts changing, you don't understand why, it's very easy to just get lost. Anyway. So if there are no more questions now about these slides, I'll go and open up a map and we'll start. So what I'll probably do is I'll start doing do a map from scratch. So select some documents, create the map, and then we'll have a look at various bits and pieces quickly. All right, so I'll unshare that and then share that. Okay. So this is Leximancer. It's the desktop version of Leximancer I'm using here. That's obviously a completed project with the concept map on display. But I can quickly go and create a model. If you haven't used Leximancer before, you got a fresh copy. You'll open it up and it'll look like that. Just with two project folders over here. These are project folders. They're not data folders. Lex stores projects separately from data. So these are project folders. The one you want to start off with is your Leximancer projects. And the way to drive this is usually you pick the folder you want to work in and you right click and then you get some options. Now, if I want to create a new folder under that, I can do that. I can go new folder. We can do that and put the name of the folder. If I was starting a new research project, I got a new set of data and I want to do maybe multiple analyses, I would create a new folder under my Leximancer projects. So I'm just going to create webinar. There I've got a folder. There's nothing in it at the moment. So now I'm going to create my first project by right-clicking on that folder and go create project. So let's just call this, I'm just going to quickly do a survey, which is a fairly short survey of data we've got. So I create a new project. It lives under webinar folder and it opened up the control panel. So this is the model builder. If you like, it's like a pipeline or a factory, assembly line, where you push in data in this end here, and out this end will pop the model. So to get the data, now, as I said before, a Leximancer project it's not like you don't load your data into your project. Not really. What you can do is you can this project can be attached to a set of data or a subset of data. What I'm doing here is I went select documents and now I'm going to find where all my text data lives on my disk. So this is my hard disk actually that I'm browsing through here. And I keep all my data in a folder directly under my home folder. I call it text data and I put it all in there. So I've got a whole lot of folders in there. So I can always find my text when I want to do a new project. So I'm going to go into my training data here, and here's this survey. So this survey was like in Excel, if you like, in a spreadsheet. From Excel, I saved it out as a CSV file. That's one of the common exports or save as options in Excel. CSV stands for comma separated value. And if you're going to load an Excel spreadsheet into Leximancer, you do need to save it out of Excel as a CSV file and load that into Leximancer. So if I do that, just drag it across into this box here. This is the data set that this project is going to explore. I could do multiple files. If I want to do a whole folder, so if I wanted to analyze this survey sorry, it's a collection of transcripts of a commissioner inquiry. You've already seen the map. If I wanted to do all those documents, basically put the documents into a folder on your disk and drag the folder in. That way you don't have to do all the individual files. Okay, but I'm just going to do this CSV file here. One survey. Okay, so I've bound or attached this project to a set of data. And I could go and change settings. And there are settings under each of these buttons. They're described in the manual. And I don't have time today to take you through the full training on this. But essentially what these stages do, this extracts the text from the documents and turns it into words, sentences, and paragraphs, and actually separate files as well if your data set has separate files. This stage here extracts the keywords, the key concepts, or the key terms from that data. Then this stage here does the latent concept discovery. So by the time it gets here, you've got, why don't I start it? I mean, we can go back and have a look at some of the settings if we have time, but so this has generated or extracted the keywords from the text. This is a survey. These are the top 80 keywords from the text content. It's also extracted the demographics. So if you're into mixed methods, maybe you've got quantitative or categorical variables associated with the content. Here, because it was in a spreadsheet, there was a column called age in the spreadsheet. And you can see all the values for age that were in that column. And each of those has been turned into a variable. There was a column for the date when the response was supplied, well, actually the month. So you can see those values have come in as variables. The gender, there was a column for gender, and male and female were the values. There was a column for position, whether they were faculty members, administrative staff, or students, and a satisfaction score. So these are my categorical variables coming in to be to give me a mixed methods approach, which I can then correlate these variables with the concepts that are mentioned in the responses. So that's what you have at this point here. It's brought in the tags. Some people call it metadata, and it's brought in the keywords from the content. This thesaurus learning will then go and take each keyword. You saw the keywords here. It goes and finds the vocabulary, the latent concept associated with each keyword. So it will build a concept behind classroom, a concept behind campus, behind difficult, etc., and behind helpful. And so let's run that. Okay, so now the code book is ready. We've got a dictionary of latent concepts, plus we've got the tags. If I wanted to put those together into compound tags, which is what some people would call coding frames or templates, you can glue these together. So you have classrooms and computers. I could make a compound concept here. So there's a new concept I've created, which has glued together two of the automatic concepts into a pair of concepts. So this will now code for places in the text which mentions the concept of classroom along with the concept of computers. So you can do that if you wish. You don't have to, but it's there to do some very complex coding frames in the compound concept editor. In this stage here, concept coding settings, we can control the coding. So this is like getting all your research assistants together into a room and supplying the code book of concepts and telling them what to code into the text. Now, maybe there are concepts that you just don't want them to use today because they're not interesting for this current research question. So you don't have to code with every concept or with every tag. And in fact, if you do want to code with any tag at all, you have to tell Leximancer that. It does not code for these tags by default. But if I want to code for like gender in my responses, I tell it that. So these are the concepts that will be used for coding. Now, you see over here, there are these cryptic things called all concepts and all discovered names. All concepts it's a directive, tells Leximancer, code with all these concept ideas over here. Now, if I don't want them, get rid of that wildcard, that directive, and now you can go and select which concepts you do want. The easy way to do most of them is to tick the box at the top, slide them all across, and then get rid of the ones you don't particularly want. Well, actually, I quite like sure because it has a lot of affect. It's to do with certainty. But if there's something here that you really don't want, they're all kind of good, actually. They're all meaningful. But for example, if I didn't want assistance, you just take it out. So that puts it back on the shelf. So you have full control now over what you code the data with. Now, some of these discovered proper nouns up here, I probably don't want. So I'm going to take all discovered names out and just put in, they're kind of meaningful for that university, but university is not. It's over at a university, so of course they're going to mention the university. So I'm going to leave that there. So here I'm controlling what's going to be coded into the text. There's more options here, which I don't have time to go into now. Don't use kill concepts unless you understand what it does. If I don't want to code for something, if I want to take it off the map, you take it out of this list here in the first tab. So I close that, save those settings, and now I can just run it. Now this is doing the coding, and once the coding is done, it will build the concept map and a couple of other reports, well, exports, so we can have a look and see. So here's the thematic map. It's made of concepts. So each of these gray dots, let's make that more obvious. Okay, so now you've got gray dots. Some are bigger than others. These are more connected. So we can do a reveal and show, okay, what are the most connected concepts in this map? What are the parents, the big mountain peaks, if you like, in this concept terrain? So it's computer and use. It kind of makes sense because it's a survey about using computers. It's an IT survey. So that's kind of nice. And we can characterize the map. So this is probably about usability around here. Here is more precisely about computers. So we're moving down now. So here we've got helpful desk and people. So I'm characterizing this region is more about the service aspect. This is about computers and, well, let's see. It's about computers, home, open, lab, probably about accessing computers, I'd say. Technology needs. Up here we've got training and equipment, teaching equipment in classrooms by the look of it. So what I'm doing here is I'm using this as an artifact to generate hypotheses. Now, you shouldn't stop just with the map. You should never stop just with the concept map. You should test each hypothesis. So what is this actually about? Let's bring up, well, we could bring up equipment. Click on that. What is equipment related to? So equipment related to teaching and classrooms. So I'm going to have a look at equipment and teaching. There's two text segments where I've selected equipment. I now look at its equipment codes together with teaching in two places in the text. Let's have a look at them. So this is a place in the text, a chunk of text which is coded with equipment and teaching. And this is one too. We can export these. You can put them in a logbook. You can go and see them in their original context by clicking on this link up here. This shows you what document it came from. And if I click on it, it shows you that piece of text in its context. So this is only a short survey, so you don't see much text, but it doesn't take long for me to run it, so I don't waste your time too much with waiting. So that's looking at equipment. We might look at difficult. 3 text locations. Okay, M127 equipment is very slow and difficult to use. So you can start doing the sense making and see, what are the roles that equipment is involved in, what are the relationships that equipment is involved in this material. So that's one way you can use it. Now, if you bring these colored bubbles back in, what these are hierarchical clusters. So there's a research, or there's an, I guess it's statistical analysis these days. It's come out of research and data scientists use it heavily, but it's called hierarchical clustering. And for anything where you have pairs of things related by a similarity measure, which we do, you saw the concept co-occurrence matrix, you can build a hierarchical cluster. So how similar are the concepts to each other based on shared relationships? So classes and room and students and computer, they're reasonably close together because they are connected to similar things. Students and classes both have fairly similar linkages, and that means they're used in very similar ways in the text, very similar contexts. And that means they're brought together in the model. Now this part of the map, so this is a very, very high level of hierarchical clustering. We've only got 3 clusters. This one's about using things. This is about difficulties, and this is about information systems. I know it's called on-course. That's because on-course is the most connected concept in this cluster. You should rename that. So your mission, if you remember nothing else from this, your mission in using one of these when you're going through and auditing the information space, making sense of this information space, just think of renaming each of these circles. And when you're going to rename it, you're going to have to look at the text to work out what is it really about. I've got online, library, I've got work, I've got services, probably help desk here, helpful, desk, assistance. Again, hypothesizing, but then we would go and check. What is this theme really about? And read some text until you stop being surprised, then rename it. Give it a name in your own words. And that way, having done the sense making, you can explain it to someone else. You can be their tour guide to this literature, this continent of undiscovered literature. So remember, the map is not the terrain. You need to read some of the text at least. Now, you might hope that there was an easier way to go and understand what this whole bubble is about. Well, we do have a tab here called Synopsis, the analyse synopsis, and it has, for every cluster, it has a bar in its bar chart. So here's use, here's that on-course one, and here's difficult. Now, if we want to know what this on-course theme is about, let's just click on on-course, and it'll scroll down to the part which looks at that. It lists the themes, the concepts within the theme. So all the concepts in this green cluster are listed here. And you can start to see the sense of it here: on-course, staff, work, helpful, semester, services, online, library. Getting the sense it's about systems, online systems potentially. Here are the top 5 pieces of text which support that. But I would click on this list of concepts, and what that does for you, it goes and shows you all 76 texts which support this theme. And go and have a read of them and take some quotes along the way, some verbatims if you like, to use as supporting evidence. And when you feel that you stop being surprised by a new narrative, you can then go back and, well, I always find that I can make a lot more sense of this. And then move on to the next, use the top button, move on to the next concept, which might be difficult, or it might be use, to continue making sense of this model. So with Leximancer, you're quick to get a model, but then you need to explore it, and that takes some time. But it's not time wasted, because it's time where you're learning. All the time you're going through and you're asking questions, hypothesizing, what does this part of the map mean? Let's look at the text, let's learn. So it's a very good directed learning technique to become very familiar with the text. And then when you're done, you can explain it to someone else, possibly using the map, maybe. But the map is a lot of information for another person to take in very quickly. So sometimes you might just want to write a paragraph for each theme with supporting text segments, and not put in the map at all into your paper or your report. Okay, so that's concept map quickly. There's a little tool up here if you can't find a concept, but you believe it's there. This is sorted alphabetically. So if you want to find where library is, it shows me it's over here, and it selects it and shows what it's related to. So library is related to these concepts. I haven't showed you where your demographic variables are. So if I look at the rank concept list just by frequency over here, scroll to the bottom, you can see the number of responses by females and by males. And then if I click on female, I can see the concepts that are top of mind, are most associated with female respondents. You can see there's helpful, there's online, there's support, services, navigate, people and equipment. If we go back to the rank view and show male, we can see what they're most related to. It's teaching, open, which is about access, technology, labs, information. So the ranking here is a little bit different between the genders. And you could analyze that using a rank correlation measure like Spearmans. If you want to be more quantitative about the differences between male and female responses in aggregate. If you want to look at the definitions of the concepts, the thesaurus tab shows you those latent concepts that were discovered. So these are the families of weighted terms which are found behind each concept. Again, it's not a huge set of text, so you're not going to get a huge dictionary here. For larger sets of text, you do get very, very big and rich vocabularies in these dictionaries from the latent method. But yeah, you have a little search engine here, so you can ask your own questions. So what I'm saying is, if you want to find in this text, do people talk about library and let's see, services. Do they ever use those words together? So this is a keyword Boolean search of your text. Yeah, well, there's only one, so you wouldn't expect to go and code some concepts around that. But you do have quite a lot of functionality in this little search engine. You have concept search, you have keyword search, you have proximity search, and stuff like that. So, all right. Well, it's 5 o'clock. If anyone has any questions, now would be a good time.
Andrew, I just Chal had a question earlier just about excluding the concepts and what to do when it doesn't remove it. Did that get answered for you?
It did, but I think I was doing it at the front end in generate concepts.
Yeah. No,
not doing
this
it in there. So
this is why this is here. So you can remove them here, because if you remove them before the machine learning, if you get rid of them here, sometimes they can come back because the machine learning.
That's what was happening for me.
Yeah, if it finds the machine learning can rename concepts if it finds a more relevant term floats to the top of the list of relevancy, and they can come back. They can reanimate if you like. So, but here you are after the machine learning, so here is you have full control.
Yeah, cool. Makes sense. Awesome.
Okay.
I'm going to have a lot of reading to do before the next go around in the next month, so I'll have more queries in the next go around.
If there's no more other questions, did you have a technical question you'd like to ask?
No, that was it.
All right. Okay, cool.
Yeah, that's what it was.
Okay.
I might ask about integrations. Any chance this can integrate with other tools like SPSS or?
If you want to get export data to go into SPSS or Stata or other statistical or network analysis packages, you look at data exports here, and ignore this. You won't see these. These are just diagnostics that I use, but you'll see there are by default you can download. The easiest to understand is number 5. So it's actually the concept co-occurrence matrix with frequencies in each cell. Now I showed you that before. You saw that. So it's that concept by concept matrix with the counts of how many times they co-occur. If you want to get if you want data which a lot of people use stats packages, like you have a row for every observation and a column for every variable. So in this context, it would be a row for every text segment and a column for every concept and tag. That's export number 4. So you can turn that on if you want to load that into SPSS, if you like. And I can show you where to turn those on. They're not on by default because when people are analyzing gigabytes of text, this can slow it down a bit, creating some of these exports. But we can turn them on by going concept coding settings. The fourth tab here is called options. This one here, generate table of context block classifications. So you get a limited text output listing the concepts tagged into each context block through the data. So that'd be the one I would create for statistical modeling. And so you turn it on and you can choose a statistics type that it uses in each cell. So some models require integer values. So you could have counts, or you could have weights, which would be a decimal, a weighted score, because some more like data mining techniques require real numbers, like a decimal. So if we choose counts, let's turn that one on and then run that last stage again. Okay, so now you've got export number 4 is available. So I'm going to download that, put it on my desktop so I can find it. All right. So I'm going to stop sharing. Now I'm going to find that export on my desktop.
Thanks, Charles. Appreciate the time coming out.
I've got to jump out.
Okay. If you are stuck with something, obviously there's the support at Leximancer email. Flick an email through to there. When we can help, we'll help.
So that's what it looks like anyway.
Yep.
I need to tidy up. It's actually tab delimited, so I need to tell Excel that. Anyway, it's there if you need it. It's tab delimited. Just be aware of that.
Yep. Easy to work with. Cool.
Perfect. Have a great one.
Okay.
Now, guys, just obviously, I'm just mindful. Andrew's taking time out to assist us today. Are there any other questions before we let Andrew go? I'm glad you're doing this, Andrew, because this, I wondered how we export it out with some other things. So, you're teaching me something new today, which is great.
So this tells me what file each piece of text came from. It tells me this is a spreadsheet. So this tells me which text cell each piece of text comes from. You can see I've got 2 sentence chunks from the first cell, starting at sentence 1 and sentence 3 within the response. So this is a 2 sentence chunk of text starting at sentence 3 in the first text cell in the survey. And now across here, it shows you what it was coded with. Now, you're not going to get, it's only maybe 1 or 2 sentences, so it's not going to be every concept. So we would call that a sparse matrix. We can see over here, it's got the female tag associated with it, so we can tell it's a female. Not sure which concepts. You can see here there are some concepts. A lot of zeros. That's because 2 sentences usually only has a couple of concepts in it. But this is a sort of input you would use to take into a statistical package to build like logistic regression, or perhaps some of the other machine learning models, or a decision tree rule set model. So it does enable quite a few other multivariate and data science types of modeling techniques to be able to get that. All right. No other questions at this point?
No. Nothing on chat. There's only one more with us. So look, I think we'll wrap it up there. Andrew, thank you so much for your time. Always worthwhile. We will get this up on the YouTube channel as well in due course after some editing. But another great resource of ours. It's got some instructions in terms of how to run surveys, interview transcripts through Leximancer. So if you're not subscribed to the Leximancer YouTube page, well worthwhile. Thanks again, Andrew. Have a lovely evening.
Thank you very much, Lucas. Have a good one.